Should we get started? Yeah, okay. Let's get started. So let's take a look at alphabetic shift over here. What is this question asking us? Oh, well, I guess I should delete this stuff, which was from last time. Spoilers, jeez. Okay, so sorry about that. This is the first task that I've redone, so that hasn't happened yet. In fact, okay, well, okay, just save that. So let's go back out, and just for the sake of like editing, you know, just for clipping this for YouTube, let's pretend that didn't happen, I guess. And we're gonna re-enter the task. So is everyone ready to look at task 28, alphabetic shift? Great, let's take a look at it. Okay, so alphabetic shift is giving us a string. It's asking us to replace each of its characters by the next one in the English alphabet. So like, for example, if it's E, it's going to become F. If it's Z, it's going to become A. So it kind of like loops around is the idea here. All right, so they give an example which is crazy, and it ends up being this baz when we replace every letter with the next one. So C goes to D, R goes to S, etc. And you'll notice that the Z that's in there, and I think that's why they chose this word, because it has a Z, it becomes A, or it's replaced by A. All right, so this is actually kind of a familiar thing. This is something that if you've been introduced to any kind of like cryptography, you've probably seen this before. So this is learncryptography.com. This is called a Caesar cipher. And so basically the idea is we're just shifting some number of letters here. In this case, we're shifting each of these right 3. Really, if we think about it the way we're going to do it, basically the idea is that A is going to go to B, B is going to go to C. So our cipher is going to be a bit different from this particular one. That's fine. It's still the same sort of thing. So all that to say, this is kind of a common thing. It's something that we sometimes want to do. Okay, so maybe what we'll do is we'll start by writing a function that I guess we'll call it getNext, and it's just going to take in a character, like one character at a time. And the idea is that we want to use this function to return the next letter. That's the goal here. So let's talk about how we're going to do that. Let's try to develop a strategy for getting to the next letter. I want to look at this as visually as possible. So let's see. I want to go to my whiteboard here. So I'll just load that up. App.com. There we go. Let's start drawing. Whoops. Okay. So here's what we want to do. Basically, we want to come up with kind of a process for this. So we'll start with our letter at the top, our original letter, and then we'll do a set of steps here that's going to get it to the end. So basically, starting with our letter, we're first going to subtract the character code for A. And when I say character code, I just want to remind you guys, I mean, I'm talking about the ASCII table over here. So we've seen this before. It's basically like if you want to convert a letter into a number or vice versa. Okay, so we're going to be using that. Now the character code for A is just 97, lowercase a specifically. It's 97. So when I'm talking about this, like I'm talking about 97, but I'm just going to call it A for now. In fact, even in our code, I think that's what we'll do. We'll just say like const A is assign the value of A dot character code at. There we go. All right, so basically now we just have this constant. I mean, we could even keep this like outside of the function if we wanted to. It's just something we're going to be referring to. We don't have to do this. It's something I like to do because it is a constant that we're going to be using. We could just say 97, but the main thing is that this shows us that it's the character code for A, so it kind of represents it a little better, I think. Okay, so we're going to subtract our 97 from the number. Then after that, the next thing we're going to do is add 1 to the number, because that's what we want to do, right? Get the next character, so we're going to add 1. And then we're going to do a mod 26, and we'll talk about that one in just a minute, but we kind of have a preview of it over here back on Learn Cryptography. This is mod 26 thing. So if you think about it, 26 is kind of like the number of letters in the alphabet, and maybe that's not a coincidence. Anyway, at the end, we're going to add back on the character code for A. So again, that's 97, but we've got it stored as A over here as a constant. Okay, great. So I want to look at a couple examples. So let's just grab a letter from here. Let's go with N. Okay, so that's 110. So we're starting with N, which is 110. Okay, great. So 110, basically part of that would be the 97. Part of that is going to be 97. Then on top of the 97, there's going to be this additional 13 over here. That's the idea. So 97 plus 13, that would give us 110. So this is just a way of representing the number. I'm trying to keep it visual. Now, the reason I want to do this is because we're going to subtract A. So we're basically taking off this part. So at the next step, we have this here, which is 13. Okay, then we want to add 1 to that, so it's going to get a little bit bigger. It's going to be 14. I'm so sorry about these rectangles. I'm writing with a mouse here, so it's probably even generous to call these rectangles. Anyway, the point is we're doing 14 mod 26. So remember, mod 26 is basically like if you were to divide it by 26, what would the remainder be? Thing is, 14 doesn't even go into 26 one time, so the whole thing is the remainder. The remainder would be 14. The quotient would be 0. All right, and then finally, we're adding A back on. We're going to put the 97 back onto this. So there's our 14, and then here's our 97. And what does that give us? So if we add these together, we would get 111, and that is the same as the character code for O. So that's O, which is 111. Okay, there we go. So we went from N to O. And you might be thinking, that seems really complicated, you know? It seems like more work than you need to do, because really we just went from 110 to 111. Like, couldn't this just be the only step we have to use? You know, just adding 1? So yeah, good point. Let's look at another example that's maybe going to illustrate this a little bit better. So specifically, I want to look at the major exception here, the one that they specifically mention within the description, which is that Z should be replaced by A. That's the only one that's a bit out of the ordinary here. So, okay. We've got our 97. We've got some extra bit. Now, what is the code for Z? It's 122. So this is going to be Z, which is 122. And so that means there's an additional 25 on top of the 97. That's the idea here. Okay, and the 25 is the part that's going to remain after we subtract off that 97, after we subtract the character code for A. And then we're going to add 1 to that, which is going to give us 26, which is, of course, a little bit bigger. We're going to do 26 mod 26. Okay, so this is where things get a little strange, because 26 goes into 26 itself. It goes in one time, right? And there's no remainder there. So basically what we get after the modulus is a big old 0. There's nothing there. Okay, and then finally we'll add back on the 97 from the character code of A. And we find that, well, okay, I realize it's the first day of school. I don't want to get into any calculations that are too strenuous or anything, but 97 plus 0, I think it's going to give us 97. Okay, and specifically 97, well, I don't think this is going to be too enlightening, but 97, it's the character code for A. It's the thing we've been using this whole time here. So this is going to be A. So this is good. This is the behavior we're looking for. Z is getting mapped to A. Okay, so this is basically the process that we want to follow, and that gives us our new letter. Yay. Okay, great. So we'll follow this process. We'll basically subtract the character code for A. We'll add 1 to the number. We'll mod that number by 26, and then we'll add A back onto the total afterwards, and that's going to give us our new, well, I shouldn't say our new letter. Technically, it's our new character code, and this is what we're starting with up here is our original character code. So let's do that. we're going to start this, and this says get next with an input of character. We want to return the next letter. So the way we're going to do that is, let's be more specific. So first, get the character code. All right, that's our first step. Whoops, let me just make some space here. Okay, so we're going to start by getting the character code. Once we have the character code, we're going to subtract A, and then we're going to add 1. And whoops, don't know how that got tabbed over. We're going to subtract, actually first we're going to mod 26. And yeah, I don't know where those indents are coming from. And then we're going to add a back on. That's really messing with me, the way that indentation keeps going in. Oh well. And then the last thing we'll do is return the new letter. Great. Letter. Okay, great. So, okay, get the character code. So let character code be assigned the value of character dot character code at. There we go. And then we want to subtract A. So I guess we could say something like let new code be assigned the value of character code minus A. We want to add 1, so new code plus plus. Then we want to do mod 26. Maybe we can do both of those and in one step. So like new code is assigned the value of new code plus 1, and then all of that is mod 26. Keep in mind we do need the brackets here because otherwise it would just be doing 1 mod 26, which is just 1, so it would just be adding on 1. So that not quite what we're looking for. Okay, great. And then add A back on, so new code plus equals A. Oh, now wait a second. Okay, I'm getting a bit of an issue here. I'm noticing that A is not being recognized despite being declared out here. So I wonder if that's part of the behavior of const. Like if it was var, I know these would have access, but I'm wondering if const maybe has a different behavior. Let's find out. Okay, so then we want to return the new letter. So we'll return string.fromCharCodes. This is one we've seen before, but basically the idea is that we want to get the letter corresponding to this new code. And that's the thing we're returning here. So let's see if this is working. Okay, that indentation is really bugging me. Is it this? Like, is that what's causing it? I just don't know why it keeps indenting like that. Anyway, let's try returning get next with, I don't know, just, what did we use before? It was n, I think, right? So we should expect an O coming from that. Or an error, maybe something to do with the A over here. We'll find out. There are a couple of strange behaviors happening right here. The tabbing is a weird one, like the way it keeps wanting to indent the next line. No, but it is giving us O, so I'm not sure what's going on. I mean, maybe it's like a bracketing thing or something like that. I'm not really sure. Anyway, we'll try not to let it bother us. I guess, like, if I were to put this back in, I wonder if that would stop being an issue. So, okay, there's that. Oh, boy. There's no in between there. Do I have to use spaces or something? I'll just enter that. Okay, this is a new issue. I haven't seen this one before. This is, yeah, not something I'm familiar with. What about this one? Okay, so that's just spaces. Is it just that my indent size has increased or something? Oh, this is really strange. Okay, I don't exactly like what's going on with this. Is that a settings thing? Can I change my indent size? I don't know. Okay, so I guess I'll just use spaces for now. That's, I'm usually more of a tabs guy, but oh well, desperate times, right? Okay, so let's run this. Let's see if that's still working. If we're getting next on this, and yeah, that was giving us O. Let's try it with Z and we'll see if we get the A that we're expecting coming out of that. We're getting A. Okay, so great, that's nice. I guess we can start using this. So unless, well, okay. Maybe we'll just do this, then add A back on. And we'll just put that after, so plus A. Let's try that. Okay, great. So that's still working. All right, so we've got our get next working, our constant a is working. So let's do this a little differently. Let's actually make this happen now. So we'll say let new word. I guess I'll call it output string just to sort of mirror what we have over here. So output string is going to be, it's going to start as just a nothing. And then from there, we're going to do a for let I be assigned the value 0, I is less than input string r, yeah, don't like that plus plus. I'm just wondering if there's a better kind of loop I could be using here. So yeah, I think so. I'm going to, okay, here's the issue, right? Because I basically want to be saying output string plus equals get next, and then what am I getting next of? Well, it's going to be something like this. It's going to be a character, so I'm going to say let character be assigned the value of input string at I, there we go, and put character in there, and then at the end of that we want to return our output string. Okay, and it looks like the indents are working properly now, so I don't know what the issue was before, but anyway. Okay, so that's good. That's passing all the tests. But the reason I was saying we maybe want to use a different for loop is because notice like this is the only time we're using I here. So instead of that, we could just say let character of input string, and then we can get rid of that. And all we have to have here is this output string plus equals get next character. Okay, great. Nice stuff. Okay, and something that we haven't really talked about in a while, but it's worth mentioning, is that we've got this get next function down here. It maybe seems weird that we're referencing get next before it's even been declared, and like even the editor is kind of a little freaked out by that. You know, it's keeping get next in green. So the reason this works is JavaScript has this behavior where it hoists functions to the top. So basically, when it's trying to compile and run this code, it's saying, oh, there's a function. All right, get that to the top, and yeah, basically pretend it's up there. So anything referencing it is not going to be like, oh, what are you talking about? Reference there. Anyway, the point is that's a behavior that I believe is unique to this type of function. Like if we were to just say let get next be assigned the value of function with character, would this still work? You know, if we're using a let, is it still going to hoist it? And so no, it's saying get next is not defined. I don't know if that's a let issue, or like, you know, if we made this a var, I think it would probably still have the same issue. Yeah, get next is not a function. So keep that in mind, and especially keep that in mind for when we're doing arrow functions, right? Because for an arrow function, we wouldn't even have that function keyword. Oh. Man, we're having some issues today. I'm on French keyboard. Okay, so there we go. If we were doing something like this, I mean, this is fine. Like the function still works. It's an arrow function. It'll work, but it'll only work properly. See, I'll try to run it, but it'll only work properly if we actually move it to up here above the rest of these guys. Above, well, basically, importantly, above where we're referencing it. Okay, so anyway, just a note about hoisting. So function get next, we'll just make it the way it was before, might as well. Okay, so there's a function that's get next, our constant a, which is at the top. We're basically doing the stuff to the string, like we're actually producing our next output string down here. This is the main. This is, you know, where the actual action is happening, corresponding to our input string. Like there's no mention of input string in any of the stuff up here. Okay, so what do we want to do next? Maybe there's another way we could do this. And yeah, there is. So one of the ways we can handle this is we can use a map, right? We want to map all the characters to basically the next character. We're doing the same thing to every single character here. So could we just do something like this? Could we say return input string dot map, and then, you know, x gets mapped to get next of x, and maybe instead of x, I'll just be a little more descriptive and say character. Yeah, let's try that. So we'll try mapping each character to the next character. And we're getting this issue where it's saying, but input string dot map is not a function. This is a string. It's not an array. So let's make it an array. So there are a few ways we could do that. I mean, we could do array.from, or we could do .split. Either way, it should work the same way. So we can try this one. And now, since it's splitting it up into an array of characters, and notice I'm using the empty string so that every single character is a new element in the array. And now it's giving us the right letters, but it's still an array. So we've got to join it back to being a string, a word. So there we go, .join, also with an empty string as its argument. Okay, great. And then, like I was saying, it would also work if we did something like this, array.from input string, and that way we don't need this split business over here. The reason I kind of like that, the array.from, is that it's a little more descriptive in the sense that if we didn't know any of this stuff, this would probably be more clear that we're actually converting it to an array, as opposed to the split, which doesn't necessarily imply anything about an array. Okay, now unfortunately we don't have, as far as I know, like a corresponding, like, string.from or something like that, so we'll use join for now. And this looks like it's working pretty good. So return array.from input string.map and .join. Okay, but there's just one more thing about this, which is that our map is basically making this new function that takes an input of character and gives an output of get next at that character. In other words, our function is just doing get character to every one of these things. But this is already a function that takes in a character and gives us the next character. So we don't actually need to define a new function in here. We can use known functions. So we can use get next in here and it should work just fine. So there we go. And that looks a little nicer. I mean, this is looking nice and compact. It's, I think, better than what we had before. So let's try submitting this. Let's see if that works. There we go. Okay, great. So it's passing all the tests. It's working good. Can we do it differently? Yeah, we probably could. So let's see. I guess I'll copy this stuff. And I kind of forgot that we sort of had a working method before. So yeah, I think this was also good, right? This is working, pretty sure. Yeah, okay. So let's get rid of this and then we'll paste what we had in. And we'll archive that as well so that the reader can sort of see the progression over here. And then we'll do one more thing with this. And the idea here is that we're using strings, right? Like we're looking at some properties of strings. So since it's strings we're talking about, I want to see if we could use a regular expression, right? So regular expressions are generally useful when we're talking about strings, when we're trying to analyze some behavior, trying to spot some patterns in a string, or even, if we're trying to do like a replacement. So in this case, .replace. I mean, just to show you, like .replace is quite a versatile and useful function. It can be used in a lot of ways. So if we just say input string.replace, replace A with Z, or actually it's the other way around, right? We want to replace Z with A actually. So if we run that, that might actually pass one of the tests. Yeah, it is passing one of the tests because the second one is just A. So, or it's just Z and it gets mapped to A. But anyway, so looking at this one, now instead of crazy, it's saying cray. And the reason is because it's just replacing that one Z with an A. Okay, so we don't want to replace it. We don't want to replace just a Z. We basically want to replace any character. So how do we do that? Well, regular expression. We say, let's take anything from A to Z, right? That's what we're looking for, anything from A to Z. And we want to replace it with not just A, we want to replace it with something else. But for now, let's see. Let's just replace it with, I guess, like underscore, let's say. See if that works. And notice how it's only hitting that first one there. It's not getting all the other characters. So this is something you might remember when we're working on regular expressions. You can set a flag at the end of these things. Now, specifically, the flag we want to use is lowercase g, which stands for global. So since we're putting the g on the end, now it's going to match all of these instead of just the first one it finds. Okay, so we're going to run that. We'll see how it goes. And there we go. Okay, so that almost looks like like an emote or something like that. I guess this does too. But anyway, the point is we don't want to replace it with an underscore. We want to replace it with the next character, right? So the way we're going to do that is we're going to put a function in here. So there's a function which takes in a character, okay? And basically the way this works is our first argument here is just going to be whatever the regexp matches, okay? So whatever match we have here, that's what character is. Okay, so if this was something more complicated, like if I made this like, yeah, make it more than one character, right? It's not just matching a single character, it would match the whole string in that case, which I don't want to do. So we want to do this one character at a time. What do we want to do with that character? We want to return get next of that character. So whatever we return here is what it's going to be replaced with. So we'll run that and we'll see if that works. Okay, great. So we're using kind of traditional function notation here, but could we use our arrow syntax? Would that work? Character gets mapped to get next of character. And we'll just delete some of these things. Let's see if that still works. So can we use an arrow function? Yeah, we can. Well, now what I'm wondering is, could we do the same thing as what we saw downstairs with the dot map, where we basically just replaced it with get next? Because if you think about it, a function that takes in an input, feeds that input to this function, and then gives you back the output of that function, well, it's doing nothing more than what this function is already doing. So if we run this, is it going to work? It's going to work. Okay, great. I'm glad we talked about that. That's replace. Let me know if you have any questions, comments, or concerns. One of the things I guess you might be wondering is that better? You know, is it faster? Faster than this was, like the dot map or just going through the loop? And my short answer to that is I don't really know. Maybe my better answer is I don't think it really matters in this case, because like one way or another, we're talking about taking a string and going through one character at a time. I don't think there's going to be any significant differences in runtime between these, but who knows? If we were to pop into like a JS perf or something like that, we might find that one of them is 11% faster or something kind of marginal like that. Anyway, I think this is probably pretty good. Again, I don't know which one's best. They all pretty much use this for all of them. I don't think I changed this at all, although we could have, you know, we could have tightened this up a little bit, but I think it's fine like this. The main thing is we wanted to see not so much how we were going to create this get next function. The main thing is we wanted to see how were we going to apply the get next function. So basically our options were we could just go through a loop, very manual kind of way of doing it. We could use a map, which feels pretty natural for a situation where we're doing the same thing for everyone. I guess the disadvantage here is that we're converting to an array, then mapping, then joining it back up. So I guess that would be a memory concern, but probably not if they're just 10 character strings. So basically, yeah, maybe this one's best. I'm not sure. Maybe the loop's best. Who knows? Anyway, I'll submit that. So in case anyone wants to take a look, they can click on solution number 5081. Okay, there we go. And it'll give you this. Okay, so ATD285 says, I've been trying to think about when to use map, filter, etc. over for loops. It seems like array methods aren't quite as flexible in case you need to break the iteration at any point. Yeah, exactly. Like if you're not trying to iterate over every element in the array, for sure. Like sometimes we've started at 1 or something like that. So yeah, in those cases, I usually like to use a loop. What I'm finding is I'm kind of getting the sense that like maps and filters and stuff like that are used a lot in functional programming because they don't really use loops. I mean, it's all about immutable data in those cases. So, if you wanted to get into functional, you'd probably be using a lot of maps and filters and stuff like that. But here's the thing, right? Like, you can sort of take care of that as you need to, right? Like I think there was one in the past where we wanted to start a loop at 1, and the way we handled that with a map was to do a slice starting at the first element. So, there are ways we can do it, but yeah, a lot of the time it is easier to just do a loop manually. Anyway, let's see. I'm seeing some cute avatars here, so okay, very nice. Always approve of cats. All right, I think we're done with this one. 5081 if you want to take a look. Let's move on from here. So our next one